Okay, so today we are starting with the CRO. Let's look at how it works. Then we're going to move towards how to solve the questions regarding the CRO. Very basic and very simple concepts regarding CRO. Nothing to worry about. Okay, so first we have the heater coil and the heater current. What basically happens is that this actually heats up the cathode. This heater, when current passes through it, it heats up the cathode, and through the cathode, there is a process called thermionic emission, right, which actually calls for the emission of electrons from a high temperature metal surface. So since it is heating up, it will start releasing electrons in all direction. Now anode is positively charged. Why? We've done that deliberately so that electrons which are negatively charged will be attracted towards this. Now the anode does two things at the same time. What it does is it actually absorbs any electrons that are shooting off, right, and only allows a certain amount of electrons to pass through it, so that these scattering electrons can become into a form of a beam, right? Now then we have horizontal deflection plates and vertical deflection plates. What they're basically doing is that on the graph on the screen of the CRO, they're basically controlling which way the electron can go, right? So the horizontal deflection plates actually make sure that the electron can go towards the left or go towards the right side, right? And the vertical deflection plates make sure that the electron can go up or it can go down. So these plates basically control the y-axis on the screen, because the electron can go up and down, right? And the horizontal deflection plates control the left and right axis, which is basically the x-axis on the screen. So the electron can go towards the right side or towards the left side, whichever way you want to look at it, right? So that is how the screen or the graph of the screen of the CRO is filled by the CRO, right? Now you will generally see x-axis and a y-axis on the CRO's graph, right? What do we call them? So this is going to be called, this is y-axis, but it will be called in terms of CRO as y gain or simply gain, and it represents voltage wherever the CRO is connected, right? And on the this x-axis will be called the time base, from which time is generally going to be measured, right? So and the values or the graph values represented on the scale are represented as divisions, right, along the x-axis and along the y-axis. These are divisions, right, which he will refer to as div for short, right? He will say, or he will write down that this is just div. So if he says that y gain is 20 volts per div or division, that means that one of these boxes or one of these lines represents 20. So this will be 20, this will be 40, this will be 60. And if he says that the time base, for example, time base is, let's say, 10 milliseconds per division, right? That would mean that he's referring to the x-axis, and one of the boxes, one of the divisions, refers to 10 milliseconds. So this will be 10, 20, 30, and 40, and so on, right? So that is how we're going to look at the CRO's graph and its values. Now let's go towards the actual diagram of the CRO. This is what the CRO looks like generally, and this is the graph space of the CRO where you see the graph, right? So here we have a few settings which we can control, and they basically control how the graph actually behaves on the screen, right? We will go to that later. And this is one of the you can say visuals of CRO as well. Now this is the graph of the CRO. They represent it with a reference line for y-axis and x-axis, right? And over here on the CRO you can see that we have time per division. We have different settings which we can select so that we can change what one box represents. Now since this is time, I will be talking about the x-axis, right? And if we are looking at volts and divisions, volts per division, then we are actually talking about the y-axis, right? Now we can generally show two graphs at the same time. That's why you see two values for voltage, right? Because we can connect two channels, we can connect two inputs to the CRO, but that's beyond the scope of the syllabus. Now first we are going to measure voltage, and then we're going to look at time intervals. So as discussed previously, that the y-axis will be representing voltage, right, and the x-axis will be giving us the information of time. Okay, so he says that it is an AC voltage, and let's understand. The AC graph will be like this. This is your AC graph, alternating current, right? It is changing. The DC graph would be in this shape. It could be either in the positive axis but of a fixed line. It could either be in a negative axis but with a fixed line. It will not be changing. We'll look at the question as well. Okay, so the time base setting is 25 milliseconds per centimeter. Now this is per centimeter, which means this is one division that I was referring to, right? Which is sometimes referred to as div. Okay, so this 1 centimeter represents 25 milliseconds, and the y-axis or the y gain, which is the voltage, is 5 volts per centimeter, which means this one division or one division of 1 centimeter will represent 5 volt, right? So since the first question is about measuring voltage, we can see that the peak voltage it can attain is either plus 5 volts or it could be either minus 5 volts. Since it's an AC signal, the voltage on the positive and negative side remain the same. So even if I have the information about one side of the voltage, the other side I can predict to be the same voltage but with the negative sign. So my voltage or the maximum voltage as per the question is 5 volts. But if the graph, let's say, had gone up to a slightly different value, for example, if the graph had gone up to this point, right, then this is 10, this is 5, then this is somewhere in the middle, so this would have been 7.5, right? And if, for example, the graph had been drawn like this, for example, then most definitely this will be 10 volts now, and this will most definitely be 10 volts as well, right? So since these are the current conditions, we're going to answer the question accordingly. So my maximum voltage is 5 volts. Now I'm going to move towards the time, right? Now he mentions what is the time taken for the oscillation, for one complete oscillation. So what is one complete oscillation? It starts from this point, one crest, and then we have one trough. This is one complete oscillation, and it takes 1, 2, 3, 4 boxes. It starts from this point and finishes at this point. It takes 4 boxes to complete this one wave, right? So we know that one box or 1 centimeter represents 25 milliseconds. So 25 milliseconds for one division. Then how much time is required for 4 boxes or 4 divisions, right? So we can very easily calculate that. So 4 multiplied by 25 milliseconds, that would be 1000 milliseconds. 100 milliseconds, right? So now if we want to find out the frequency, which is not asked in the question, we can easily do that. So frequency is equal to 1 over t. Now we put 1 divided by 100. Now since this is milliseconds, please be advised, we should add a prefix of 10 raised to the power minus 3. If you don't know this, if you don't understand this, then you're supposed to convert this into seconds. And how can you do that? You can just divide 100 with 1000, right? Because 1 millisecond is equal to, or you can say 1 second is equal to 1000 milliseconds. So to convert that, we have to divide it, right? Or you can just add the prefix from the prefix table that you should have memorized by now, and then whatever answer you get, that will be in hertz, right? Okay. Now again, over here we have to measure voltages and time interval, but this time around notice that this is a DC signal. Previously we have been working with an AC supply. This is an AC signal because the voltage is changing at all times. This is a DC signal. How can we see that? We can see that very clearly, that this line that is drawn at this point is a fixed solid line. Its voltage is not changing. It has a fixed value, right? And where is our origin? Where is our reference point? This is our reference line, and most definitely the very center becomes the reference line for the y-axis, right? Now since DC is a direct current supply, its frequency is generally 0 hertz. The question regarding the frequency for such a graph will not be asked because it's not changing. It is a fixed value throughout its time. Now it says that Y gain is 4 volts for each division, which means that in short he's saying that this is 4 volt per division, right? This is 4 volts per division, right? Now then he asks you about the voltage. How can we find out the voltage? So if one division or one box is worth 4 volts, then this is 4, 8 and 12. So the voltage of this supply is actually 12 volts. Now how do you connect a CRO? For example, if this is the voltage or this is the battery that you're connecting it across, and let's say this is the resistor, this is another resistor, for example, then you connect the CRO exactly like a voltmeter across the supply or across the image or across the element that you want to measure the voltage of. So this is your CRO, right? It behaves exactly like a voltmeter. If you want to connect it across a resistor, then that would again come out as over here. The symbol for CRO is a bit like this, right? Okay, now we move towards the next question we have. Okay, so he says that we have 4 volts and alternating voltage. The graph is going to look like this, right? The answer is already given to us, but let's see. And the frequency 25 hertz, the Y gain is 2 volts, which means that we have to represent 4 volts of the graph on a graph where the voltage division is 2 volts. That means that I will need 4. I will need 2 boxes along the y-axis to represent my signal successfully. And the frequency is 25 hertz, and he says that it is 0.01 seconds per division across the x-axis. So what I do is I calculate f is equal to 1 over t. I replace both positions, so this becomes t equals to 1 over f. This becomes t equals to 1 over 25, right? Which becomes t is equal to 0.04 seconds, right? Which means that this one wave will take 0.04 total seconds. Now we have 0.01 seconds for one division, right? So I will need 4 boxes along the x-axis to represent it completely. Why? Because 0.01, 0.02, 0.03 and then 0.04. So one of my waves should be completed in this space. 2 boxes up, 2 boxes down along the y-axis, and then 4 boxes along the x-axis. This is where one wave should be completed, right? And then I have next 4 spaces for the next wave, and so on and so forth. So let's draw that wave over here. So we start with this. Now notice how the graph has been drawn, that we have taken 4 volts up to this point, which was mentioned in the question that the graph should be 4 volts. The output of the alternating voltage is 4 volts and has a 25 hertz signal. Now we can see that our wave is being completed in 4 boxes. So if I multiply this 4 with 0.01, which is what's given for the division, this becomes 0.04 seconds, which was the frequency of our signal. So we have successfully drawn it, and in a much better way it's drawn over here, right? Okay, now these are some past paper questions. Let's look at them. It's an AC signal, okay, because it's connected with generator, and its voltage is changing constantly from between a positive to negative, right? Okay, again, when it says it is to generator, that means that it is being connected in parallel to the generator like this, and now the voltage is being measured from an AC supply. Okay, now it asked me which row describes the amplitude and the type of signal. So it is an AC signal, that is for sure. It's not DC, because if we want to look at DC signal looks like this one, a fixed line at a certain voltage. It's not changing. So this is not an AC, this is not a DC signal. And then we move towards the amplitude of the wave. Now amplitude is towards just one side, so this is how I divide my signal in half, in the positive side and in the negative side, right? And it tells me that one division is 2 volts. Now since it is volts and it is being mentioned as Y gain, that means I have to look for the y-axis. So on y-axis I can see that this is just one box, and then the second box, and somewhere in the middle this value is somewhere in the middle. So this will be 2 and 4, so this looks like 3. So the voltage of amplitude should be 3, and the most common answer we get is option A. It is an AC signal and the voltage we're getting is 3. So if I zoom into this, basically what's happening is that if these are two lines for the y-axis, our graph is actually passing like this. So this was 0, this was 2, and this is 4, right? So it's somewhere in the middle, so this should be 3 along the y-axis, okay? This question is from October-November 2020 P12. You can go through that question and zoom into the diagram as well. This is one of the common questions that students sometimes find difficult. Now, first, we have to identify what type of signal this is. This is an AC signal. And how can we say that? This is the shape of the graph. So this is alternating between a high voltage and a low voltage, right? And our concerned signal, since we want to find out the repetition, since we want to find out where the signal is being repeated and how it is being repeated, because generally what we see is that an AC signal looks like this. But if the signal goes on like this, then it becomes a bit difficult to understand or to figure out where the signal starts from and where it is ending. So if you started from this point, then you take one crest and one trough, right? If you started from this point, let's say, then you take quarter of this and then quarter of that, that becomes a full wavelength. So you have to decide from which point you have to pick the starting and ending point. So over here, let's decide, let's choose this as our starting point, or you can choose this as our starting point. So the wave actually looks like this, right? So this is my one complete wave actually going through the cycle like this. This is my one complete wave. And if you notice, or if you compare this with the sine wave, which is the generator, then this is what it actually looks like. This is what it actually looks like, the blue one, right? But it is in the square shape right now, nothing to worry about. Okay, so it tells me that the settings of the CRO are given as below. So the Y gain is set at 2 and the time base is set at 0.01 seconds, right? So first I figured out that along the y-axis I have covered two boxes. One box is worth 2 volts, so this will be 0, 2 and 4. So the voltage I'm supposed to select is supposed to be 4 and 4, right? Option A and B will be cancelled since they represent the first value incorrectly. Now we move towards the time base. Now see, my graph is actually existing between these two extremes. If you see that this is the selection that we've made, right? So this is box number 1, this is box number 2, and one of the boxes represents 0.01. So this will be 0.01 plus 0.01. The total time will be 0.02 seconds. So this whole wave has taken a 0.02 seconds time to complete. So to find the frequency, we have the formula f is equal to 1 over t. That will become 1 over 0.02, which is going to become 50 hertz if you calculate this with the calculator, right? So then we have 50 hertz. And since option A was giving incorrect voltage, this is not the correct answer. The correct answer will be option C, right? This is all for today.